All right, today we're starting a new chapter. It's section 5.1, and this entire chapter will involve us working with quadratic functions. And I purposely gave you some unusual spellings of absolute value, and this is something that we're used to because we've been graphing absolute value functions, and we've already looked at the fact that they produce V shapes, or they could be upside down V's. Well, in this chapter, when we do start to graph quadratic functions, which will be tomorrow and pretty much throughout the chapter, the graph of a quadratic function produces this U shape that's technically known as a parabola. Now, it could be upside down, but I hope the spelling just serves as a reminder of what the graph will look like. So what I want to do with this lesson is the main objective, I guess, in the beginning is to see if you can identify what a quadratic function looks like. And what I've provided for you here at the bottom of this slide is a very important standard form for a quadratic function. So in general, using just variables, this is what the standard form quadratic function looks like. Notice that the highest exponent for x is squared. This just means a restriction on the variable a. Obviously, if a is 0, then we don't have a quadratic term, so then it's not a quadratic function. So hopefully that makes sense. So let's just jump right into looking at some specific examples that will help you with the first 9 problems of tonight's assignment. Okay? So here's another couple of important items that you should have in your notes. Quadratic functions have a degree of 2, and linear functions have a degree of 1. I need to make sure that you understand what I mean by what is the degree of a polynomial function. And so before you write any more, after you've captured these 2 blue sentences, I just want to go to the next slide and just do a brief review of what it means to find the degree of a polynomial function. Okay? So you got the blue sentences. All right, let's just take a look. You don't have to write these down. I just want you to observe. You got this in Algebra 1. I just want to give you a reminder. So I'll do this first one for you. This function has a degree of 2 because 2 is the highest exponent for x. I have an exponent 2. There's an invisible exponent 1 here, but obviously 2 is bigger. So we would call this degree 2. And more specifically, we would say that this is a quadratic function. Okay, well, let's contrast that with my second function, which the highest exponent for x in this case is this invisible 1. It's the only exponent for x. So therefore, we would say that this is degree 1, and for degree 1, we call those linear, because that should be pretty familiar. That's the graph of a line that has a slope of 4 and a y-intercept of 3. We're not going to get into higher degree functions, higher than second degree, but just by way of review, somebody raise your hand and give me the degree of this third function. So, Eli, what would you think?
3.
All right, it's degree 3. And again, we're not going to get this far yet. This will be more of Chapter 6 material, but can you tell me what that is, what the term for degree 3 is? Anybody? You remember that from Algebra 1? No? Well, this is called cubic. That's kind of a look ahead to a future lesson. Reagan McCamey, what's the degree of number 4?
4.
It's 4. That's the highest exponent. Do you remember what the term for degree 4 is? Future lesson, but think how many quarters in a football game? 4 quarters. Remember that? Does that ring a bell? Well, 4th degree is literally called quartic.
Quartic.
Okay? So, again, Our focus is going to be, can you distinguish between a second degree quadratic and a first degree, which is called linear. I just want to make sure that you understand how to find the degree, because without that information, it's going to be difficult to do the rest. All right, so we're about to do some examples of problems 1 through 9. So to begin with, we need to answer the question, is the function linear or quadratic? So that'll be the first answer that we provide. And then based on that answer, we will identify the various parts of the function. All right, so here's something that's very important, a very important first step that needs to be done before you classify as linear or quadratic. If there are parentheses in the expression, they need to be removed first. Now that's going to involve distributive property sometimes. In our particular case with letter A, it's going to involve that familiar FOIL method that you learned in Algebra 1, because I'm multiplying two binomials together. So let me see what you remember about FOIL. Let me see, Olivia, if you multiply the first terms of each binomial together, what would you get? 2x times x?
2x squared.
2x squared, okay. Let me go to Hannah, and you do the outside terms together. What would that be? -8x. Minus 8x. Chloe, multiplying the inside terms together.
3x.
Plus 3x. And Reagan Adams, the last terms together. -12. I always want to combine like terms to simplify this. So hopefully you can see, combining the x terms in the middle, we end up with y equals 2x squared minus 5x minus 12. Now I'm ready to answer the question, linear or quadratic. So Jake, what do you think? Quadratic. The highest exponent for x is 2. So it's okay with me if you just abbreviate. This is quadratic. Now I'm going to go to the next part of the answer, which is to identify the quadratic, the linear, and the constant terms. Okay? So, Reagan McCamey, what's the quadratic term?
2x squared.
2x squared. Nick, the linear term? -5x. And the constant, Dylan? -12. Okay? And that's the complete answer. And you're going to do 9 problems very similar to this. The key is remove the parentheses with whatever method is required. Make the decision on linear or quadratic, and then break up the parts. Okay? Let's try a couple more. We've already done that. So letter B. Just raise your hand if you want to take letter B. And we need to remove the parentheses by using the distributive property. So what's that going to look like? Someone. Okay, Eli.
You multiply within the parentheses by -1.
Okay. So give me the final result.
-6x minus 2.
Okay. Not sure why you're yelling, but that's all right. So we got y equals 4x squared minus 6x minus 2. Okay. No like terms to combine. So I'm ready to make the decision on linear or quadratic. Let me get Morgan. What do you think? Okay, quadratic. And now we're going to identify the quadratic, the linear, and the constant term. So Dylan, what's the quadratic term?
I believe it's 4x squared.
I believe you are correct. Cody, the linear term.
-6x.
All right, very good. And let me get Miles, what's the constant? -2. All right, it's pretty easy, right?
Yes. Yes, sir.
Somebody want to take letter C? Letter C. Let me get somebody different. I'm going to get James. I've given you a pretty good hint here. We need to multiply these monomials together. What would that result in?
So, 15x.
Very close.
X squared. Yeah.
Okay. And then minus 3. Okay. Micah, let's answer the linear or the quadratic question.
Quadratic.
Right? It's quadratic. So, Emily, what's the quadratic term? Good. What's the linear term? Nick?
There is no linear term.
Very good. So, we'll just say none. And the constant, of course, is, Dylan?
-3.
-3. Okay. Just for sake of time, I think you get this. We're going to skip letter D. And let me see if someone wants to raise their hand and give me the answer for letter E. JT. It is linear. Okay. So obviously, if it's linear, then there is no quadratic term. Hannah, what's the linear term?
X.
And what's the constant, Nick?
That would be -10.
Okay. So 9 of these. You get the idea? It's very important that you remove parentheses first using whatever method is required. All right. Any questions on 1 through 9? All right. Very good. You don't have to write this down. If you need to, you can come back and watch this later, but I don't think this will give you any trouble. Problems 10, 11, and 12 are going to be just like this. You're going to be given the graph of a parabola. You're going to look at the graph, and you're going to write down 2 answers. What is the vertex of this parabola? Which, for a parabola, that means either the very bottom, if the parabola opens upward, it's the very bottom point, or if it happened to be upside down, it would be the very top point. We need to identify the ordered pair of the vertex, so let's just go ahead and do that first. Olivia, what's the vertex of this parabola?
It would be 1, -1.
Okay, so 1, -1 would be the vertex, and then we have to identify this other term called the axis of symmetry. So for every parabola, you can think of a line that basically splits the parabola into 2 equal parts. It always goes right through the vertex. It's going to be a vertical line. And think of the axis of symmetry comes from a term that literally means sameness. It's exactly the same distance, for example, on either side of that vertical line between these 2 points. It creates 2 equal, same halves. All right? Here's the deal. We all have our pet peeves, right?
Yes.
Okay.
Yes, sir.
I got a few of my own. Here's one of my pet peeves. I'm just kidding with you, but in all seriousness, I will be very angry if you. No, not really. Here's what I want you to do with the AOS. Okay, the AOS is always a vertical line. There is a way that we write a vertical line in equation form. It always starts with what variable? Reagan.
Why?
That is not true.
X. It's X.
Yes, because this line is crossing the which axis? It's crossing the x-axis. So the equation for this vertical line is x equals 1. That's the AOS. So I'm trying to give you a heads up for those people that will have the tendency to say the AOS is 1. Please don't do that, because the AOS is always a line, and it's always a vertical line, until we get to the inverse of these, which would be a parabola laying on its side, which you're not going to have to worry about in Chapter 5. So in Chapter 5, the AOS will always be x equals some number. And what's an easy way of remembering what that number is? Anybody? X equals 1. Where does the 1 come from? Hannah. All right, and what part of the vertex? The x-coordinate. The AOS will always be the number that is the x-coordinate of the vertex. So it's easy to remember. Okay, I got one more of these. So let me see, Reagan Adams, can you give me the vertex for this letter